I've been teaching chromatography to professionals since 1984. We've just talked about the importance of the concept of resolution. Again, it's not a theoretical topic, but a very practical, very applied topic. If you cannot resolve your peaks in chromatography, we can't do anything else. We can't identify, we can't quantify, we can't purify until we get resolution. There's a great tool available on the Chromedia website that allows you to really investigate the details of resolution. So here's the resolution tool. And as you can see here, our goal is to get a resolution of at least 1.5. In this case, we have a resolution of 1.96 because I have the appropriate capacity, selectivity, and efficiency. You'll see what happens as I start to change these parameters. If, let's say, I buy a better column, so instead of a 5,000 plate column, let's say I get a column with 22,000 plates. You see that the peaks are now skinnier than they were before. The skinnier the peak leads to a better separation. So higher efficiency means skinnier peaks means better resolution. You'll also notice that if I take this back down, you'll also notice that if I get more interaction with the column, higher capacity factor, this also leads to higher resolution. So what we're doing here is we're getting more interaction. The more interaction leads to more separation. So capacity factor is a way to answer the question, did you allow your analytes to interact with the stationary phase? Selectivity is the quality of that interaction. So let's say I just have a capacity factor of 2. So I'm getting decent interaction with the column. If I make that interaction better by using a higher selectivity, you'll see a dramatic improvement in the separation, in the resolution. So selectivity is the correct choice of stationary phase, mobile phase chemistry. You could see that, let's say I bought the world's best column, and I was at 28,000 plates. Let's say I've got incredible capacity factor of 9. If I have poor selectivity, the separation does not work. If I don't have the right chemistry, it doesn't matter how good the column is, how well it's packed and how well it's plumbed. It doesn't matter how much interaction I get. If that interaction is not good interaction, then it will not allow separation. By the same token, if I buy a column that has incredible selectivity, in this case selectivity of 2, if I have incredible efficiency of 30,000, if I use the incorrect capacity factor, again, the peaks are not going to separate. The reason here is capacity factor of 0 means everything came off in the void volume. The analytes did not spend any time in the stationary phase. All you need is interaction with a column, and once we get some interaction with a column, we will see that the separation is there immediately. So we need all three. We can't get away with resolution unless all three terms are there. We need the right capacity factor, again, ideally between 2 and 10. We need the correct selectivity, again, ideally at least 1.2, and we need enough efficiency. We need the correct column dimensions to give us skinny peaks in order to give us a good separation. So this tool that you'll find on the Chromedia website really is great to answer the question, how much selectivity do I need? How much efficiency do I need to get a separation? So if you have an efficiency of your current column and you say, I'm limited to 5,950 plates, you can ask the question, how much capacity factor would be required in order to get the separation to work? So it's a useful tool and something that's practical, applied, that'll help you improve your separations.